Good afternoon, students. Yes, we were studied about thermodynamic, isn't it? In the last classes, we were studied about thermodynamic. I want to just refresh those concepts again, okay? Thermodynamic is a branch of science which deals with the interconversion of heat, isn't it? Here we study about interconversion of heat from one state to another state. So that is known as your thermodynamic. Clear? After that, we studied about some important terms of thermodynamic. First one is system, second one is surrounding, and the third one is boundary. So first one is system. It is nothing but it is part of universe which is under study. See, if in case whatever, if I use a beaker or a bottle and which is under study, in that case this whole thing is known as system. That means the liquid inside this beaker or inside this bottle is known as system. Clear? And remaining everything in the universe is known as surrounding. So this is a difference, isn't it? And surrounding and the system will be differentiated by a boundary. That may be imaginary boundary or it has a wall which difference or which separates system with the surrounding. In this case, the bottle, this one is nothing but your boundary. So here further we studied about system. That means types of system, isn't it? How many types of systems were there, students? So these are very important questions for 1 or 2 marks. Types of system. So there are 3 types of system. First one is students, just reply. First one, closed system, open system, and isolated system. If in case I'll consider open system, energy can be exchanged, both energy and matter can be exchanged, isn't it? So first one, in case of open system, if I consider any liquid in this case, we can exchange water or liquid, isn't it? If in case I'll consider hot water, what happens? In this case, heat may be released to our surrounding or heat may be absorbed by the system. This is open system. Further, another one is closed system, isn't it? Closed system where energy can be exchanged but matter cannot, isn't it? Why? It is a sealed container. It is a sealed container. See, if in case I'll consider this bottle which is closed, isn't it? Which is closed. If I considered hot water in this case, it may be lost by this container. That means heat may be lost. But if in case we considering any matter, it can't be exchanged. That means it remain as it is because it is a closed container. Clear? And the third system is isolated system. Third system is isolated or isothermal system. What is this? Here, no exchange of energy, no exchange of matter. Clear? So product or the content which is inside that system will never be exchanged and the energy also remain constant. That means there is no change in energy also. That is known as adiabatic process. That means heat energy, change in heat equals to 0. That means heat remain constant. Clear? So this is the main 3 system or types of the system. Further, we consider properties of the system. What are the properties of the system, students? What are the properties of system? So there are 2. First one is intensive property. Second one is, yes, extensive property. First one is intensive, second one is extensive. What do you mean by intensive property? Intensive properties are nothing but these are a fundamental property. Students, yes, it is independent on the matter or the quantity. I'll consider quantity of matter which is inside the system. Clear? So that means it is independent. Intensive property. What are the example for intensive property, student? What are the example? S. Pressure, then pressure, temperature, density. So these are nothing but example for intensive property. So that means if I consider 100 ml of, if in case I'll consider 100 ml of 100 degrees Celsius, 100 degrees Celsius water, if in case I'll consider 100 ml of 100 degrees Celsius water, and I'll just take off 50 ml of solution or 50 ml of water in another container. 50 ml of water in another container. In that case, what will be the temperature of this system? See, so this one is a system, this one is another system. If the system which contains 100 ml of water contains 100 degrees Celsius, and I'll just remove 50 ml of water in another container, what will be the temperature of that system? Yes, it will be 100 degrees itself. So that means temperature remain constant. That means it will never depends on the quantity. Clear? So now I'll consider simple example. Now I'll consider 100 kg of 100 kg of substance. That is nothing but mass, isn't it? 100 kg of any substance. I'll consider sugar or whatever it is. 100 kg of mass. I consider first system, and I'll consider it as 100 kg of a matter which is filled in the system 1. So now I'll just remove this. I'll just remove 50 kg of substance in this case. 50 kg of substance in this case. So now what will be the weight of this system? That means, yeah, weight of this system, 50 kg. 50 kg, and here it is 50 kg. That means the system or mass depends on the matter which is present in that system. Clear? So that's why remember, extensive property is nothing but it depends on the quantity of the matter. It depends on quantity of
Jai Mataji.
matter. Clear? It depends on the quantity of matter which is present in the system. Is it clear, student? Is it clear? Huh? So these all things we already studied.
Yes, sir.
And the example for extensive properties, mass, volume, isn't it? So those are nothing but example for extensive property. Further, we considered state of system and state function, isn't it? What do you mean by state function, student? What do you mean by state function and path function? What do you mean by state function and path function? So what is state function?
Path.
What do you mean? Okay, listen. So state function, what do you mean by state function? What do you mean by state function, student? Yes, anything or any property, fundamental property, I'll use here fundamental property, which depends only on, initial and final state of the system. Remember, student, in this case, state function, it is a fundamental property, or these are a fundamental property which depends only on initial and final state of. So next one is about path function. Next one is about path function. What is this? path function depends on the fundamental property. So these are fundamental property which which depends on path through which the system is carried out. Path on which the system is carried out. Is it clear? Is it clear? If in case we have to consider an example, state function is nothing but your internal energy, enthalpy, entropy. So these are nothing but, yes, state function. And the path function, there are two path functions were there. One is work done, another one is heat. So these two are path function. Okay? Is it clear, student? Is it clear? Okay, so now after that we studied about internal energy. What do you mean by internal energy? So internal energy is nothing but it is a sum of all type of energy. It is sum of all type of energy which is associated with the system. Clear? If in case I'll consider any system, which is filled with the gas, ideal gas or whatever it is, kinetic energy, vibrational energy, whatever the energy present in that system. So those are nothing but all, sum of those all energy is nothing but internal energy. Clear? Yes, Prithvi, that's true. Next one. Further, we studied about first law of thermodynamics. What do you mean by first law of thermodynamics, student? What do you mean by first law of thermodynamics? Yes, energy cannot be created nor be destroyed, but it can be converted from one state to another. Isn't it? Energy cannot be created nor be destroyed. So that means we can convert it from one state to another. Yes, the energy of isolated system is also, that means energy is conserved, that heat is conserved. And the mathematical expression for first law of thermodynamic is very important. Delta U is equals to Q plus W. Delta U, that is internal energy. This one is nothing but internal energy. Q, what is Q, student? Q is nothing but heat. What is W? W is nothing but work done. Clear? So now there are four system or four condition. First one is heat absorbed. Second one is heat evolved. Third one is work done on the system. Next one is work done by the system. Just tell me, what will be the sign of these two? Q. Heat is absorbed by the system. What will be the charge over Q? Q is very good. It is positive. Q is positive. See, it is positive. So next one, heat is evolved. Heat is lost by the system. Heat is given out by the system. So that is negative. Very good. That is negative. Clear? So next one. See, work is done on this system. If in case I'll consider a system which is fitted with a frictionless piston, see. So now I'll pressurize this piston inwards. That means work is done over the system. See, work is done over the system. What is W value? Work is done. That means external pressure is applied. Yes, work is done. That's why it is positive. W value is positive. Q value is negative. In this case, Q value is. Next one, work done by the system. See, what is work done by the system? So that is, see, now internal pressure is more than external pressure. Internal pressure is more than external pressure. That means what happens? Piston will move upwards. So that's why it is negative. Work is done by the system. Energy is lost by the system. So that's why W value is negative. Clear? So now we can write this equation in 4 terms. Clear? So if heat is absorbed by the system or work is done over the system, or else these all things we already studied. Clear? So now I'll consider another important thing which is also already discussed. So that is nothing but expansion of or expression for work done by on the system for the expansion and compression on the system, very important, on the system for isothermal process. See, so here we are finding, yes, that is true. Here we are finding work done or the expression for the work done which is done on the system. See, students, here I'll consider one system which is filled with a frictionless piston. See, so for example, syringe. Here I consider one system which is fitted with one frictionless piston, and I'll fill this system with the ideal gas. See, I'll fill this system with ideal gas. Clear? So now listen, if I consider the pressure which is exerted over this piston is Px. Clear? I'll consider P external, and the pressure inside this is, I'll consider as P gas or P internal. So now listen, student, now listen. If external pressure is supplied over that system, what will happen? If external pressure is applied over the system and which is more than that of P internal, that means internal pressure is less than that of P external, what will happen? Yes, compression. That means piston will move downwards. Piston will move downwards, isn't it? Piston will move downwards and it will reach somewhat this state. Okay, this will reach somewhat this one. Is it clear? Yes, volume will be changed. First one, initial volume, as we consider it as VI. What is VI? It is initial volume. What is VF, student? It is final volume. Is it clear? So now, when piston move from the level 1 to level 2, in that case, the distance moved by the piston is, I'll consider it as L. Clear? And the cross-sectional area of that piston, is, I'll consider it as A. Clear? A is a cross-sectional area of piston and L is nothing but distance moved by that piston. So now see, student, volume change, I'll consider delta V. Volume change is equals to what? Length into or distance into cross-sectional area. So that I'll consider L into A. Is it clear? Delta V is equals to L into A. Okay. So next one I'll consider pressure. What is the relationship between pressure and force, student? We already know. Pressure is equals to force divided by area. Force divided by area. Therefore, force equals to, I'll consider force equals to pressure into area. See, force equals to pressure into area, and delta V is nothing but L into A. Clear? So next one here, whenever pressure is applied over the system, see, pressure is applied over the system, that means work is done on the system, isn't it? So that's why I'll write work done equals to work done equals to, work done on the piston equals to, what is the formula, student, here? Work done equals to, yes, that is force into distance. Force into distance. So now I'll just substitute the value in this case. P, here pressure is external pressure which is done over the system. So that's why I'll consider it as P external into A, area, into distance, I'll consider L. Clear? So now what is this? What is this? A into L or L into A? Yes, that is delta V, change in volume, delta V. See, work done equals to P external into delta V. Is it clear how this was? That means P external, what is delta V? V final minus V initial. In this case, we consider minus here. We consider minus here. Why we are considering minus? See, work is done on the system. Work is done on the system. That means W is positive, isn't it? So now delta V value is negative. See, V final is less than that of V initial. So that's why we will get negative charge here. To balance or to get W as a positive, we have to consider minus charge. Is it clear? So this one is for compression. This one is for compression, student. So now just imagine the pressure is not constant. Pressure is not constant over this piston. That means pressure is variable in this case. In that case, we have to consider its integration from V final to V initial or V initial to V final. See, if the pressure is not constant, if the pressure is not constant, in that case, the formula is work done equals to integration of this one from VI to VF minus P external. I'll consider delta V as a dV in this case. Small changes, isn't it? If pressure is applied, it moves small portion. Again, I'll increase the pressure. What will happen? Again, it will move downward. That means volume decreases slowly. That means change in volume is very small. So that's why I'll consider dV. Okay, if sudden change will be there, it is delta V. If the changes will be limited, that means small, infinitesimal, in that case, it will decreases slowly. That's why I consider it as dV. Clear? So now listen, P external is equals to P internal plus dV. When the system will come, that means P internal, if we add something to P interval, that means small portion of pressure. If I add it to internal, in that case, P external will be equals to P internal plus dP. What will be the condition when it will form? Yes, for compression. This is for compression. I'll explain how it is. See, whenever you are getting compression, the resultant process is compression. In that case, P external is more than P internal, isn't it? If compression is a resultant procedure, in that case, P external is more than P internal, isn't it, student? So in that case, what will happen in this case? If I have to balance these two, in that case, I'll add something over here, isn't it? So that is nothing but dP. Now, P external is equals to P internal minus dP. So what will be the system? System at expansion or compression? It is at expansion. See, what will be the system here? P external is less than P internal. So that means, see, Internal pressure is more than external pressure. Just imagine, student, internal pressure is more than external pressure. That means expansion will take place, volume will increase, isn't it? So internal pressure increases, that means it will expand, that means volume increases, isn't it? So that's why this is for expansion. So this one is compression, another one is expansion. So now listen, I want to consider reversible reaction. See, in this case, I want to consider reversible expansion or reversible process. What will be the thing? We know reversible process, we can reverse the process at any instant of time, isn't it, student? So that means compression and expansion will be there. Yes, so that's why P external is equals to C. In a reversible process, in a reversible process, there may be expansion, there may be compression. So that's why P external equals to C. P internal. If in case I'll write a plus, it is compression. If I write minus, it is expansion into dPc. So this is for your reversible process. So that means system may be expanded or compressed. It is in between. That is, it is reversible. Clear, student? So now I'll just substitute this value here. I'll just substitute the value in this case. This is for reversible. If the reaction is irreversible, this is your final statement. That means this is your final equation. But the system undergo reversible reaction. In that case, it will change. See, now W equals to V initial to V final. See, I'll consider I'll consider reversible reaction minus P external will be converted, or it is replaced with this one, P internal plus or minus dP, isn't it? Into dV remain as it is. dV remain as it is. See, I already explained that change in this pressure is very low. dP is very small. Clear? When we compare dP and dV, both are small changes. So that's why dP and dV, I'll consider it as dV itself. I'll consider it as dV itself. So now see the reaction. What will happen here? See, W equals to V initial to final minus P internal pressure, then it will remain dV. Is it clear? Is it clear, student? Just we exchange P external with P internal. Clear? So now we know the relationship between PV and nRT. PV is equals to nRT is nothing but ideal gas equation. It is ideal gas equation. Clear? So now what is P, student, in this case? P is equal, just cross multiply. P is equals to nRT divided by V. Substitute this value in this equation. What you'll get? W equals to integration from Vi to Vf, P, that is minus N into R into T divided by V into dV. See, in this case, N is constant, R is constant, and T is constant. So that's why I'll consider outside nRT integration of Vi to Vf of dV by V. Isn't it? Now, what is integration of 1 by x dx, student? Integration of 1 by x dx. It is log x, isn't it? It is not a natural logarithm. You have to consider natural log. That means ln. Clear? We consider ln in this case to the base e. So that's why the formula will be nRT ln of v. See, integration of 1 by v dv is equals to ln v. So that is from vi to vf. vi to vf. Is it clear? Next one. Minus n into rt. Clear? Convert ln into log. How will convert? Log into 2.303 is equals to ln in this case. So just substitute the value of ln here. 2.303 into log of, what will get? Log of Vf divided by Vi. Yeah, actually you'll get log of Vf minus
Jai Modi ji.
log of Vi. Log of Vf minus log of Vi, but log A minus log B equals to log A divided by B. Log A minus log B is equals to log A divided by B. Is it clear how this equation comes? See, actual thing is, he in this case will get, see, in this case, it is log of Vf minus log of Vi. That means log of A minus log of B is equals to log A divided by B. Clear? So that's why we got this as a final equation. So finally, we can write in this form.
Ma'am, somebody is talking.
So now we'll get final equation. W is equals to minus into nRT. That means I'll
Am I
write it.
audible?
So who is speaking? What happened, Sandeep? Sandeep? Who is this Sandeep? Okay, listen, student. So this W is equals to 2.303 into N into RT. See, final statement, log of Vf divided by Vi. So this is very important, which is for reversible reaction. See, work done expression. This is work done expression for reversible reaction. And another one, so that is W is equals to P external delta V, P external delta V. This one for reversible reaction, sorry, irreversible reaction. And this is for reversible reaction. This is for reversible reaction. And this is for irreversible reaction. Is it clear, student? Yeah, in this case, we use P internal. That means in case of reversible, you use internal. In case of irreversible, we use external. That is the difference. Okay, Prithvi? Is it clear? So now listen. Now, is it clear, student? Is this clear? Work done expression. See, first we have to consider pressure and that means delta V. L into A. After that, we have to consider force. That means pressure equals to force divided by area. After that, you have to consider work done. Clear? Work done expression. So you get this whole thing. Clear? Okay. So now listen one thing which is very important. You have to remember, see, this expression is not for your, that means this derivation is not so important for your board examination, but you have to remember what was the expression for reversible reaction and what will be the expression for irreversible reaction. You have to remember that, okay? So derivation is not needed for your exam, board exam. Is it okay? Student, is it clear? So now we have to consider free expansion. Free expansion. So now the question arises, what do you mean by free expansion? What is the free expansion? We know. So that means if the volume increases, it is expanding. So now the question, what do you mean by free expansion? What is free expansion, student? Listen, if the expansion of gas is present in a vacuum, there is an expansion. There is an expansion. No, it's not a zero, Shravan. We have to consider expansion. There is an expansion. But thing is, in this case, we have to consider vacuum. If air is filled in the container or the system, in that case, it is simply expansion. Yes, very good. That is true. See, free expansion is nothing but it is expansion of a gas in a vacuum. In vacuum. So now, in case of vacuum, external pressure will be what? See, in a vacuum, we are considering nirvata, vacuum. In case of vacuum, what will be the pressure outward the system or the external pressure? There is nothing outside. That means there is a vacuum which is filled. That means the air is, yes, that is zero. Remember, in case of vacuum, P external is equals to zero. P external equals to zero. So now just listen. Pressure, external pressure is zero. Here we draw something, isn't it? Piston. So there is no pressure over that piston. Just remember, there is no pressure over that piston. Now what will be the work done on the system? Zero. That means no work is done over the system. See, there is no external pressure itself. That means external pressure is zero. Just think, student, pressure is zero. So that's why no work done. No work done over the system. Whether the reaction will be your exothermic or endothermic, whatever the condition, whenever you are considering free expansion, it is expansion of a gas in a vacuum where external pressure is almost zero. Clear? Then no work done. That means there is no work done over the system. Clear? So now I just jump for the first law, that is delta U is equals to Q plus W. So now I'll give some condition. You have to answer, okay? First condition is at a constant volume, what will be the equation? At a constant volume. First condition is at constant volume. At a constant volume, what will be the first expression? See, we already seen here, isn't it? See, I'll write it as delta U is equals to Q. I'll write W that as external delta V. See, delta V is equals to 0 because at a constant volume, delta V will be 0. Isn't it? So therefore, this whole term will be 0. 0 into P external equals to 0 itself. Clear? what will happen here? Delta U is equals to Q. Delta U is equals to Q. This is the first system. Clear? Is it clear? So now another system I'll consider isothermal system. I'll consider isothermal system. See student, I'll consider isothermal system. So now just tell me, for isothermal system, delta T is equals to 0, isn't it? Delta T is equals to 0. Yes, temperature will be constant. That's why temperature will be constant. Yes, very good. Delta U also constant. Delta U is equals to 0. Clear? So now listen student. In this case, if in case we are considering isothermal expansion of an ideal gas, in that case, delta T is equals to 0, delta U is also equals to 0. So now another question will be there, student. Listen. If in case we are considering isothermal reversible change, see, isothermal, yes, in that case, W equals Q is equals to minus W. So now I'll consider another system, isothermal reversible change. Isothermal reversible, see, very important, reversible change. Isothermal reversible chain. What will be the Shuddha? What is that? At dash volume. So now tell me, isothermal equation at a reversible change. Reversible. What will happen here? Just tell me. Just tell me the answer, students. See, in this case, you are asking plus or minus, Prithvi. In this case, you are asking, isn't it? Which one? Which one, Prithvi? Shraddha, what was the question? Which word, Shraddha? This one, it is isothermal system. This is isothermal system and this is isothermal reversible system. Isothermal reversible change. Okay? Isothermal reversible change. Just tell me, what will be the expression? What will be the expression? Yeah, in this case, if we consider delta U is equals to Q plus W, now delta U is equals to 0, so that's why it will be Q plus W. Clear? So now Q is equals to minus W. Is it clear how we got this equation, expression? Okay. So now the question for isothermal process and the reversible change, what will be the expression? Reversible it is. Yeah, see here, minus W is present. Q is equals to reversible. It is actually minus W, isn't it? So now I'll just substitute the value in this case. Minus remain as it is. What is the W for reversible change? What is the value for reversible change? Reversible. I already written this expression here, isn't it? Yes. What is that? Yes. Minus 2.303 n into RT log of Vf divided by Vi. So minus into minus, it is plus 2.303 n into RT log of Vf divided by Vi. Is it clear why in this expression we got plus charge for Q? Clear? See, if in case we are considering this expression, it will change. Is it clear? So now, next one. Second condition, isothermal irreversible reaction. Isothermal, irreversible change or reaction. Isothermal, irreversible change. What will be the expression, student? Again, same. Q is equals to minus W itself. But what is the value of W in case of irreversible change? Yes, that is P external, delta V. See, I'll write again minus P external delta V. So that is nothing but P external, I'll just remove this, delta V, or else P external VF minus VI. See, all are same. All these expressions are same. Is it clear? Is it clear? And the last question, this one is first one, this one is second one, and the third one, I'll consider third one, that is adiabatic process. Adiabatic process, what will be the expression for first law? Yes, Q equals to 0, adiabatic process. Therefore, delta U is equals to W. Is it clear? See, we got only one expression. That is nothing but your first law, thermodynamic first law, isn't it? Delta U is equals to Q plus W. From that, we can just borrow these all expressions. See. Is it clear? Is it clear?
Yes, ma'am.
Okay. So next one is about enthalpy. See, again, I'll explain this one. So this whole thing depends on work done expression. Clear? So depending on this, we will study about enthalpy. So what is enthalpy, student? What do you mean by enthalpy? Any idea? Do you know anything about enthalpy? Any idea about enthalpy, student? Energy. Well, which type of energy? In this case, we consider, yes, amount of heat energy present in the system is known as enthalpy. Remember, student, enthalpy is nothing but it is a total amount of heat energy present in the system is known as enthalpy, which is indicated by which symbol? So next, very important, this was for 1 or 2 marks. What is enthalpy? First question in this case, what is enthalpy? And write its mathematical expression. What is enthalpy? Yes, enthalpy is situated with H, but change in enthalpy is delta H. Okay, change in enthalpy is delta H, or simply enthalpy is nothing but H. So H, total amount of energy, total amount of, you have to write heat energy, total amount of heat energy present in the system, present in the system is known as enthalpy. Very important question for 1 mark or 2 marks. What is enthalpy? So enthalpy is nothing but it is the total amount of heat present in that system. So now listen, student, if I consider first law of thermodynamic at a constant pressure. See, heat content of the system at a constant pressure. See, I'll consider at constant pressure, delta U is equals to Q plus W. Okay, I'll just introduce the value of W in this case, Q plus, in this case I'll consider it as Q plus, or I'll write minus P into delta V. Isn't it? P into delta V. That may be external, internal. So now I'll just resubstitute this. Q is equals to, see, Q equals to delta U plus P into delta V. isn't it? So now I'll just take delta of everything present over here. See, delta U, P, delta V, and delta Q. Or I'll simply write in this case, see, U is equals to internal energy is equals to Q plus W. See, this is clear, isn't it? So now I'll consider Q is equals, that means W equals to minus PV. Okay, so now I'll substitute change in everything in this case. Change in internal energy equals to change in heat minus change in P into V. Clear? Pressure is constant, so that's why I'll take it outside. Delta Q minus P into delta V. Why? Because P is constant in this case. So now delta U is equals to delta Q minus P delta V. P is a constant, so that's why I taken out here. Now just rearrange this equation, we'll get delta Q is equals to, see student, very important, delta Q is equals to delta U plus P delta V. Yes, Q is a path function. Yes, Q is a path function, isn't it? But here we are considering change in Q at constant pressure, very important. In this case, we consider it as at a constant pressure. So that's why we can exchange this term with another term, that is delta H. Clear? So that means heat content of the system at constant pressure is called as delta H or enthalpy. Clear? Enthalpy equals to, what is enthalpy equals to? Delta U plus P into delta V. So this expression is very important. Delta H is equals to delta U plus P delta V, where delta H is nothing but change in enthalpy, delta U is nothing but change in energy, P in delta V is nothing but change in volume. Is this clear? Is this clear? Student, is this clear? See. And this is nothing but your enthalpy. How this enthalpy appears? So enthalpy is nothing but, remember, it is a change in heat at a constant pressure. This you have to remember, student. Clear? This you have to remember. So now again, I'll consider ideal gas equation. See, what is ideal gas equation? PV is equals to N into R into T. Again, I'll consider change in pressure. Change in pressure volume is equals to change in N into R into T. So now we know R is a constant. R is a constant, so that's why there is no change in R. So that's why I'll consider it as P is a pressure, isn't it? Pressure is a constant. So that's why it will be outside. Delta N into T. R is equals C. See, in this case, P is a constant, P into delta V, that's equals to R is a constant, delta N into T. Clear? Clear? Now listen, I'll just substitute the value of this in equation. What will happen here? What will be the equation in this case? See, I'll substitute this. Delta H equals to delta U remain as it is. Next, plus delta N of R into T. Delta N of R into T. Remember, delta N is very important. It is change in number of moles. That is nothing but number of moles of gaseous reactant. So that means product, number of moles of product minus number of moles of initial to final or final to initial? Final to initial, isn't it? That means final minus initial. That's why product is a final state, initial state is a reactant. So that's why delta N is equals to N product minus N reactant. So finally, you'll get this equation. Remember this equation and this equation in terms of enthalpy. Is it clear? If the question is what is enthalpy and write its mathematical form, in that case you have to write total amount of heat energy present in the system is known as enthalpy, and the mathematical expression for enthalpy is delta H is equals to delta U plus P delta V. Is it clear, student? Is it clear? So there are two types of reaction depending on enthalpy. What are those? What are those, students? Depending on enthalpy or heat, evolved or extinct. Yeah, depending on the heat exchange, there are two types of reaction. Yes, one is absorption and the one is, yeah, what are those reactions are known as? Yes, endothermic reaction and exothermic reaction. What is endo? What is endothermic reaction, student? A chemical reaction in which proceeds with the endo. What I told first, initially I told endo or exo. Okay, I'll consider exo, okay? Just tell me. For exothermic reaction, heat is evolved or heat is absorbed? Exo. Exothermic reaction. Yes, this is a chemical reaction. This is a chemical reaction which proceeds with evolution of heat, exo, or loss of heat. Whatever you want to write. Evolved or lost. Clear? Evolution or loss of heat energy is known as exothermic reaction. See, don't write heat energy is evolved, heat energy is lost. No. Exothermic, again important, exothermic reaction. What is exothermic reaction? Give anyone example. What is exothermic reaction? A chemical reaction which proceeds with loss of heat energy is called as exothermic reaction, or evolved with heat energy is known as exothermic reaction. Example for this one is carbon reacts with oxygen. Carbon is solid or gas? Student, carbon is a solid or gas? Solid. Solid. Oxygen is a gas. It gives, carbon reacts with oxygen. Combustion it is. It gives carbon dioxide. Carbon dioxide, which is again gas, with the evolution of 393.5 kilojoule heat energy. See, heat is evolved. That means in a product you got heat also, isn't it? See, carbon and oxygen is a reactant which reacts together and forms carbon dioxide with the evolution of heat. That means heat is lost. Yes. That is also exothermic reaction. So now listen, this equation itself I'll write in a different manner. See, carbon is a solid, oxygen is a gas, which both reacts together. It gives carbon dioxide gas. So this is known as chemical reaction, thermochemical reaction, where you have to mention symbol with a state of the reactant and product is very important. These are known as thermochemical reaction. Remember, student, thermochemical reactions are nothing but it is a balanced chemical reaction where you have to mention state of the reactant and product with the energy exchange that may be lost or gained. See, in this case, I'll write it in terms of delta H. See, what is the value of delta H in this case, student? Negative or positive? Think and answer. Yes, that is negative. That's why you have to write it in terms of 93.5 kilo. Delta H is equals to minus. We should write values for heat. Yes. While writing example, you have to remember any one example. Okay. Huh? Don't remember all the equations or all the values. Huh? For writing example, you have to remember any one. Okay, Pawan? Okay. Remember, delta H is negative in this case, but while writing, evolution of heat is written as a product itself. Clear? Next one, what is endothermic? What is endothermic reaction? So this one is last one. After this, I will end this session, okay? What is endothermic reaction? Yes, a chemical reaction. See, while writing answer, you have to complete the sentence. Clear? So it is a chemical reaction, which takes place or which process with the absorption of heat energy. Don't write energy, you have to mention heat energy. Yeah, heat is chemical reaction. It is a chemical reaction which proceeds with absorption of energy, absorption of heat energy, heat energy. Example student, I'll consider here hydrogen reacts with iodine, it gives hydrogen iodide or hydride. Yeah, silver nitrate decomposition, okay, that is also KNO3 also exothermic endothermic reaction. So now just tell me, H2 is a gas or liquid? H2 is a gas or liquid student? H2, hydrogen, gas or liquid? Gas. I2 is a gas. HI is a, HI is also gas. Just balance the chemical equation and tell me. Balance the chemical reaction and just tell me. Balance the chemical reaction and just tell. Yeah, 2 molecules of HI. 2 molecules of HI. So now heat is evolved. Sorry, heat is absorbed, isn't it? So that's why I'll write it in terms of delta H is equals to 53 kilojoule. 53 kilojoule. While writing, you can add minus 53 kilojoule here, or else you have to add plus 53 kilojoule in this case. Clear? Yeah, this one is positive, sorry, plus. While writing, you have to write here, see, same reaction, I'll write here, H2 gas plus I2, very important, C, 2 molecules of HI gas plus 53 kilojoule. Another thing, H2 gas plus I2 gas plus 53 kilojoule gives 2 molecules of HI gas. Which equation is right? First or second? Which equation is right? Only second one? First one? Which one? See, both are same. Both are right answers. See, if in case I'll write this here, in this case, what will happen? Just tell me. Both are same or what? If in case I'll write in the, sorry, what I write here? Okay, now tell me. Sorry, now tell me. Now, sorry. I just wrote plus charge here. Okay, now these two are same. Both are correct, isn't it? Is it clear? See, in this case, okay. If we write plus, it is exothermic reaction. Here, if it is negative, it is. Is it clear, student? What is exo? What is endothermic reaction? You have to remember any one example. Another example is nitrogen reacts with oxygen, gives nitrogen monoxide, where the value of delta H is plus 180 kilojoule. So that is also one example. Yes, photosynthesis Or combustion is exothermic reaction. All type of combustion is exothermic reaction. Photosynthesis, energy is released or energy is absorbed. It depends, okay? It depends. Is it clear, student? Yeah. Yes, Prithvi. Is it clear?